I definitely found the workings of the largest database service providers quite fascinating, and how important it is for them to predict all the bugs that might come in the way and how seamlessly they solve these problems. Now quickly moving on towards our next talk. I'm sure all of you must have heard of recommender systems, and we are all heavily using recommender systems in our day-to-day lives. So these major companies like Google, Amazon, Netflix, YouTube, all of them heavily rely on and thrive on recommender systems. So our next talk today is about the anatomy of recommender systems, how these recommender systems work and how they recommend jobs, articles and ads. Let me introduce our speaker for this talk, Uma Sawant. She completed her PhD from IIT Bombay Computer Science Department and was advised by Professor Sawant Chakrabarti. She was a part of the search sciences team at Yahoo and was also a research scholar at Yahoo. She is currently the senior engineering manager at LinkedIn and has been working at LinkedIn for more than 7 years now. She has some amazing publications in the top forum, and some of her research interests and some of her work at LinkedIn includes content discovery and quality conversations for LinkedIn groups, AI solutions for better pay and benefits for hourly workforce, improved search relevance for LinkedIn learning, and identifying and mitigating algorithmic bias. So please join me in welcoming Uma Sawant with a big round of applause. Welcome, ma'am. The stage is all yours.
Thank you so much. Hey, everyone. So I'm Uma. I work at LinkedIn for now 7 years. A bit about me. I was a master's student here at IIT Bombay. After I completed my master's, I joined as a research engineer at Yahoo Labs. Worked there for a research problem and a bit of recommendation problems. And I was surrounded by very smart people. So at that time I realized, okay, I need some more training. So I came back to IIT Bombay, did my PhD here. And after completing my PhD with Professor Sawant, I am now working as a senior manager for the AI and DS team at LinkedIn Bangalore. So I worked on a variety of problems including job recommendation, fairness for content quality solutions, LinkedIn learning search, and most recently I'm working on LinkedIn groups, how to enable the discovery, creation, recommendation, and so on. So coming to large-scale recommender systems. Okay, imagine a student like you. Let's call her Kea. She is looking for jobs. Okay. So she takes time from her courses. She has exams going on, but she's looking at maybe jobs, going through descriptions. She's not really sure what kind of jobs are good for her. Okay. So can we help her in some way? So this is where recommenders can come into picture. Right? A recommender system can look at Kea's resume. It can look at the jobs that she's interested in. Maybe she has indicated what kind of skills she has or she is looking for in the job. Right? And most importantly, the recommender system can also look at other students like Kea who have found their jobs in the past. Right? And it can put all these bits together to find exactly the right set of recommendations to give her, so she can save her time and use it constructively on other things. Right? Not only jobs, the same funda works for, let's say, movies, books, news articles, and so on. So we have a ton of practical applications touching our lives already. I want to highlight the difference between search and recommendation. Search is a use case designed for when you already know what you are looking for and you can articulate it in terms of a search query. So taking jobs as an example, if I know that I'm looking for maybe a director job, it is in skill set of AI, I'm interested in particular location and so on. So I can put all these filters, I can get a perfect set of job search results. On the other hand, recommendation works on serendipitous discovery. Right? Maybe I don't know what really I'm looking for. Here are some guiding principles. Maybe it could be my profile. It could be the search queries I have done in the past, right? So that's the difference between a search system and a recommender system, okay? All right, so in today's talk, I want to first do a collective exercise. Let's try to design a job recommender together. I'll give some building blocks, looking for your thoughts. Then I want to contrast it with LinkedIn's job recommender, which is, I want to give you some practical examples from there. Finally, highlighting some challenges and trends and takeaways. All right, let's come to the brainstorming part. Let's design a job recommender together. So to help you, these are some of the guiding principles. These are some of the building blocks, okay? If I'm designing a recommender system, which is a machine learning system, it needs to have an objective. What really do you want this system to learn, okay? It will have some constraints. You need data to learn from it. You need what kind of signals I want to, or maybe the features I want to collect from this data. What kind of modeling algorithm I want to use, and how am I finally going to evaluate this, okay? So these are the 5 building blocks, let's say. All right, now focus on a job recommender, okay? So what would you use to design a job recommender? Anybody? Job description, okay? So that's part of the signal that I want to use, yes, job description. Past work experience, yeah. Sorry? Education, yes. Sorry, interest, did somebody say interest? Yeah.
Interaction between students who have applied for jobs and
Exactly, interaction between students who have applied for a job and got them, yes. What would be your objective? You are designing a machine learning system, okay? What do you want to tell it and how do you evaluate it, right? So what's that objective? Yes, yes. That's a great attempt. But I just want to call out that person getting a job is a bit a longer signal, right? So let me approximate that, a person applying to the job, okay? Which is, yeah, not every time it doesn't turn out to be true, but yeah, let's take it as P apply. And how would you measure that? If I design a system, how would you measure whether it's working? Skills? Did you say skills? Yeah, yeah. Skills is one of the signals, yes. Yes and no. Yeah, I will talk a bit about that. Just hold on to that thought, yes. Number of applications per job. How do you want to use that? Yeah, correct. So you want to use that to refine the data. Exactly, yeah. Correct, yes. So exactly, that's how the algorithm is going to work, yes. The similarity between the yeah, so what do employers look for in a given job, okay? Okay.
maybe we can suggest random job descriptions and we can try to guess the trend that how is he or she responding to that and then generate more.
Okay, so you're suggesting that I don't know what would be my algorithm, how to train that. I will start with showing random jobs and how people are responding to that. I will keep track of that, and based on that, I will train the new model. Yes, yes. All right, let me summarize. So I did this exercise myself and I came up with some answers. Let me put that here and, okay, so first objective, right? As somebody already suggested, we want to maximize the job applies. What kind of constraints I would put, right? So finally this is a probabilistic, it is a statistical system, right? So it's going to make some mistakes, but we want to minimize the ugly mistakes it's going to make, right? Ugly and cringeworthy mistakes, right? Or I could have a constraint that, okay, I'm running a product, right? I want to make revenue. So I want to show at least X% of sponsored job, which will give me the revenue. So that could be a constraint. All right, actually let's go step by step. All right, second, data collection. Once I know that I want this member applying to this job, that's a good signal, okay? So my data collection in that direction would be, I want to gather tuples of a member, a job, and whether this is good or bad, right? One way of doing this would be to show people random jobs and the way they are responding to that job, I collect that. Or I could have humans sitting and looking at member job pairs and they tell me, okay, this is good, this is bad, this is ugly. Okay? I need to make sure this is a representative data sample. If I have just, you know, the data about computer science, it's not going to work for other job, profiles. So I want to make sure that through the right sampling mechanism, my model works well for all the member base I have. Finally, I need to do data cleaning, remove noise and so on. So this is also, together these two, make sure that the training data sample is correct. Moving on, the kind of signals and feature engine that we need to do. So we got a lot of suggestions on this. So we need to use the member profile, on LinkedIn itself, people fill in their job titles, their location, what previous jobs they have done, what internships they have done, what courses they have taken and so on. We could use that data. Apart from that, we could also do some derived data. Is this member a student? Where they applied before? Are they applied, are they employed right now and so on, right? Jobs have...
How does is employed and is student as one feature, right? How does that influence your recommendation?
Correct. Okay, that's a great question. How does is employed and is a student influence the recommendation? Yeah, I covered the question, sir. So for example, let me give some example that really happened. If a person is currently training as a student, a full-time student, and they are not going to complete their education for a certain duration, there is less reward in showing them jobs that are hiring right now, right? Or if a person is currently employed, there is less reward in showing them internships, right? Vice versa. So these kind of signals help us in doing focused recommendations. Okay. And yeah, finally, a lot of match signals between title, skills, industries, location, degree, size of company, and so on, and years of experience. Modeling algorithms. So I don't know, a lot of you are pre-final year students, but when we think of recommender systems, there are two major types. One is content-based, and one is collaborative filtering, right? Content-based algorithms, example is this. So we talked about the student Kia, she is looking for a job. Does her profile match this job's profile? Okay, so it's a and that way we are going to design the system. On the other hand, we have collaborative filtering where, okay, Kia, she looks similar to Parth, and Parth has liked or applied to, or maybe has gotten AI jobs. So we can show Kia AI jobs, right? So this kind of user-user matching or item-item matching, all those kind of algorithms fall into collaborative filtering. So we could use all these components. Finally, how are we going to evaluate and improve? So for ranking systems, usually we use metrics such as NDCG, MRR, MAP, Precision Net K, and so on. All right, so this is a general idea about we were designing a job recommender system together. Now let's look at lessons from LinkedIn, right? What is different about LinkedIn? Mainly the scale, okay. These are the numbers. Weekly job home visitors, 49 million. Monthly job applications, 234 million. And what's the time limit we get for online serving? It's in milliseconds, right? So yesterday, Pratik Urf Pawan talked about his constraint was the model has to fit in KBs. My constraint is that, okay, that I don't have, I have the server side architecture, the cloud side architecture, so model size is not a constraint, but latency and the number of users I have to serve is a constraint. So with this scale, these are the ABCs I have to keep in mind. A, if you are trying to run a complex model on a large set of users and trying to serve it concurrently, it's going to take time. You cannot satisfy the milliseconds of latency constraint you have. So you need to break down your model into a funnel, okay. What's the idea about a funnel? You run a simpler query. So given a user, you have million set of jobs to choose from. Run a simpler query, go from 1,000,000 to 1,000, okay. That's your first stage. The second stage would be a little more complex, okay. You can now afford, now you just have 1,000 jobs, you can run a more 1,000 job, more complex model, but now you can focus on the getting the top recommendations right. So first stage was about maybe recall, and now it's about precision. And finally, we have one more stage called re-ranker. So usually, businesses will have certain set of rules which have to be followed no matter what, right? So one rule could be the number of paid job applies or ads that I have to show, because I am also running a company and I have to make X number of money. Right? The other rule could be I need to maintain diversity. It's no use showing me all jobs from Microsoft, okay, even though they are relevant to me. Show me some diversity in top 10. It's interesting that while we think that theoretically all of this can be done by the second stage itself, the ranker, right? But it's a statistical model. It could fail in maybe 1 or 2% of cases, but when you may have a constraint that no, I have 0% failure rate, so you might as well put it as a rule on top of everything else that you do, right? So that's the third stage re-ranker. Are the 3 stages of the funnel clear? You have the first stage candidate selection, second stage ranker, third stage re-ranker. All right, so that was the A. What is B? You have all this data, how are you going to train it? Can you put people giving me the labels, right? Human labels is going to take prohibitive amount of time as well as cost, right? So why don't we use the member actions themselves, right, to gather the data? So when I show the jobs to users, I track what kind of views they are doing, the applies they are doing. Finally, what kind of jobs do they get in the end, right? They end up hiring. So member actions today are going to create tomorrow's training data. And how do I divide this between positive and negative signals? If I show a job and I apply on it, it's positive. If I dismiss a job, or maybe I look at a job but I don't apply, I go ahead, that's a kind of a negative signal. Right? And one caveat here is that users always trust the system, right? So the jobs which are shown at the top positions, we are going to get higher amount of views, and maybe higher, they also get higher amount of applies compared to the lower rank jobs. So we need to correct for the position bias when we convert it to training data. So that was part B, okay. Now what is the part C? Nothing can be complete without the supporting platform or architecture. So we need distributed architecture for training and serving. We also have to use prefetching as far as possible to keep the runtime latency small, right? So you could pre-compute your embeddings, keep them prefetched in the data, in the memory and so on. All right, so these are about A, B, C's of scale. Any questions so far? What is the need of what? Re-ranking. Okay. So as I said, re-ranking is usually used to impose some rules which cannot be fully guaranteed by the ranking layers. And what kind of business rules? I want diversity in the top 10 results. So I don't show me jobs only from Microsoft. Okay. Show me other companies also. The other rule could be, okay, the third position should be an advertisement, right? That way the rest of the positions could be filled by the organically, the kind of job a person prefers, right? That way you are going to balance the engagement and the revenue that you are going to get. Yeah, I have one slide on re-rankers. I'll speak a bit more.
So what would latency be a concern if you can pre-compute all the recommendations beforehand and filter based on
That's a great question. So some of the recommenders can afford to work fully offline, okay, and then they don't have the latency constraint. But jobs is one such case where you do want to look at the latest actions members have done, or the latest jobs that may have come newly on the platform, right? So there is a freshness aspect that you need to take care of. So that's where you do a balance, pre-computing versus.
How do we store the embeddings? Do we put them in our embedding index or is it any other storage mechanism?
It is a kind of index, and then there are various types of index. Some are used for, optimized for read. Some are optimized for, okay, read, but I also want to do X number of writes, like I want to keep it updated and so on. So it depends on the use case, basically. Good question. Some of the rules you could apply at the bottom, but things like, okay, I want to insert the ad in XYZ slot, right? That has to be done at the last layer. The diversity has to be done at the last layer because, or at the ranking layer if you are using, page-wise ranking mechanism. I don't know if you know about item-wise, list-wise and pair-wise. But if I use list-wise, I could assure diversity, but it's very expensive to do, right? It's just easier to put a simple rule at the last layer. So in short, it's about, is it easy to do versus complex to do? That decides where should I apply this rule.
Yeah, you talked about scale and latency, right? So, as far as I understand it, recommendations are not, they don't need to be updated like instantly, right? So, how does the inferencing part of it work, and why do you need such a short latency? Because couldn't it be like, even if the model takes a lot of time and is time complex, but if you just stored those recommendations for that user's profile until it needs to be reevaluated again, wouldn't that, like, why is the latency constraint there?
Yeah, sorry if I confused you all. I'm talking about the serving latency. If I am on the platform, when the page loads, that's the latency I get for serving side, like showing me the result, right? So any online component, any computation I am doing at the moment, that has that latency constraint. Anything I can pre-compute and keep, that doesn't have the latency constraint. So we do a balance of both. Why do you need balance of both? Because as I said, you could have fresh jobs coming up. You want to look at, okay, Uma, I could pre-compute, every day what kind of recommendations are good for Uma, but she has applied on job just 1 hour ago for XYZ title, or she has taken this LinkedIn learning course and upgrading her skills yesterday, right? You want to keep updating your recommendations based on these signals as well, right? So there has to be an online component apart from the offline component.
So most of it is done offline and sometimes it is done online?
No, actually we are moving towards how much of it can we do online, because we clearly see a benefit in doing things online.
Thank you.
So how
I'll speak a bit about it, yeah, not in full detail, but I'll give you an idea. All right, then moving on. Okay, let me give a few more detail about the funnel that I talk about and other things. So this is about the candidate selection. As I said, we want to go from million to maybe a set of 1,000 jobs suitable for a given member. Right? Traditionally, we do what is shown on the left hand side. Oh yeah. Yeah, this, so you are given a jobs database, you have an inverted index, and maybe your keys could be, okay, if for a given this title ID, these are the set of jobs. For this skill, these are the set of jobs. There is a filter on this location ID and so on, right? So given this kind of structured query, I could retrieve a set of jobs. That's how we were operating. Now the latest trend here is embedding based retrieval, or EBR. If I could pre-compute the embeddings for a job and a member, I just need to look at the match score to arrive at a reasonable set of jobs suitable for a member. And this actually has the benefit that it goes beyond the structured query. I don't have to worry about, okay, the job says machine learning. I mean, this is a very simple example, but there are many more contrived other examples, right? But I don't have to worry about, oh, I'm doing structured query on machine learning, but the job is actually keyed on AI engineer, right? So those kind of things are taken care of easily when I go to representations, right? Okay, yeah. And this part is definitely online. It's easier to do, within the latency constraints that we have. Unfortunately, this part, we haven't figured out how to do it fully offline. We call it nearline, right? So it is almost online. We do a lot of pre-computation, we do keep training and so on, but some of it is still nearline, it's not fully online. Okay, that's about the candidate selection. Next stage, I talked about ranking. It's a deep neural network. So the evolution here is, we had earlier, many years ago, there was logistic regression. From there, we moved into XGBoost, the tree networks. A few years back, we moved into this wide and deep architecture. So, okay, this diagram maybe is not representative, but the wide and deep, you could imagine, I think this was a paper by Google where they introduced this. So this is your deep neural network. So here you could actually, on the wide part, you could plug in some of the features which you believe are important and you want to make sure that the model picks it up. You could plug them in here. And this deep part is you can keep your deep neural network as deep as possible, and you could have the member and job embeddings here as well, right? So you could plug in the job description, the job title, the member profile, all here, and let the model train on it to pick up the right side. And what kind of, oh, I didn't put, so the objective here would be the p-click, probability of clicking, a member clicking on a job. You already have that training data. And yeah, you minimize the softmax cross entropy loss. Right? So there are some details on the ranker. Unfortunately, I cannot give details on the layers and the size of each layer and so on. That's a bit confidential. Any questions here?
So
Yes.
member and job embeddings are in two different spaces. So
No, I mean, I'm going to train them using this kind of architecture. So I will ensure they. Yeah, that's a great question. So your question is, even though I'm showing a sponsored job, it still needs to be relevant to the user. Exactly. So even the sponsored jobs have to go through a similar pipeline like this, that they have to be, they will also be trained. That pipeline will also be trained on whether this job is relevant to the user, and only then it can be shown to the user. Okay, here again we went through an evolution. I mean, we are going through an evolution. Earlier the pipelines were separate. Now, practically we are finding that it doesn't make sense to keep two separate pipelines. We could have a single pipeline. Yeah. But in all practical purpose, many of the signals are similar. Yeah. So to give you an example, right? Let's say you have some jobs which are paying higher. Which are paying, and you still choose to have some jobs which don't pay you anything, like company, they don't pay anything, but they need to be present, because let's say I don't have the right set of jobs to show to a cook on the platform, right? So I gathered these, I went to somebody, they gave jobs, but they are not paying me for it, like this is my need. So you could assign a shadow budget for it, that and the original jobs, the paid jobs already have a budget, and then both these jobs are now equal, they can flow through the same pipeline. Okay, I'm trying to think how to frame this. Okay, okay, there is a stage where we pre-compute embeddings. So what's the right term? Okay, so I'm currently working on an effort where we want to, I'll speak a bit more about that, where we want to pre-compute the member and job signals representations by looking at not just the jobs data, but also the, let's say, the learning, what kind of learning courses they are doing, what kind of recruiter, how do they interact with the recruiter ecosystem. So you could choose to build representations using that, and then you plug it in here as what do you call it? Pre-computed embeddings, or forgetting, it's a very common term, but it's not a tip of my tongue. But you choose that, you start from that point, and then you let the model, this architecture, train on that, right? And then it's going to tune those embeddings, the deeper embeddings. Does correct, yeah. No, sorry, the rest of the part, this part, so here I have plugged in some existing embeddings, right, trained during this. Here I plug in wide feature, and then the whole network trains together, okay. I'll come to it, yeah, that's one of the challenges. Yes. Actually, forget when did I start, how much time do I have? 30 more minutes, okay. All right, so I talked about candidate selection, I talked about the ranking layer, and now I'm going to talk about the re-ranker layer, right? So that's where I said I need to enforce business logic. So I have, from ranking gives me these set of jobs A, B, C, D ranked in certain orders, and then I have certain rules that, okay, don't show me more than 2 jobs from the same company in top 10, because, or remove the jobs that, impression discounting. If I have seen a job, don't show me to again in the the next session, right? This has to be done at the last layer, right? It cannot be part of the ranking or this thing. And then paid job slotting, as I said. So these so it converts the given set of ranking into a different ranking at the end of it. Yeah? Finally, coming to the evaluation. Now, evaluation has 2 parts. One is what you do offline. I am training a model. How do I know whether it's doing better than the previous model I launched, right? So what kind of tuning I should do. So as you might know, we use ranking metrics such as MAP, MRR, NDCD, precision at K, and so on. And we use K-fold validation, maybe leave one out to do the right set of offline tests. Okay. Now the next, so this is all about offline. How do I know this is actually going to work well? Actually the right test is actually to show to the user and see that whether it's working well or not. So it's called online testing or A/B testing platform. So large companies, because they have to do these kind of tests, okay, I'm launching a new UI, would users like it or not? I am launching this AI model, or maybe I want to add these new set of news articles coming from XYZ source, right? The right way of test this is just test it on user, right? But you want to do it gradually. So there is a concept of gradual ramp, right? First you do a sanity check, you launch it to maybe 1%, see if it is working or not. Then you launch it to the 5% of users, 10% of users, finally maximum users. And when and what kind of metrics you look at here, those would be your last mile or downstream metrics. Is it actually generating the applies? How much applies does it generate? How does it compare to the base model I have right now? Is it generating a lot of these ugly recommendations, right? That's the guardrail I had. What's the downstream sessions? How, even if maybe I'm showing the right set of jobs, but does it entice user to stay on the platform and do something else, right? I came looking for a job, but then now I'm joining this LinkedIn group. I am connecting to these many people, and now I'm looking at so many news articles. What kind of sessions is this generating? And finally, how much revenue comes from this? Right? So these are all online metrics that we look at while making a decision on whether to make this new model maximum members experience. All right. So as I said, nothing is complete without the supporting infra. There has to be an offline infra which helps me to train a model, and there is online infra which helps me to serve the model. So I kept this intentionally kept this slide a bit lightweight, but there is a lot more complexity here, and ML infra engineering is one of the most important jobs that is there right now. Right? So, okay, how does the system work? So as a user from front end, I am first going to visit the jobs page, okay. That will send down a query. So there will be a one infra component here called the mid tier that is going to look at this query. Oh, this user is Uma, here is Uma's data, supportive data. It could be Uma's profile, it could be the member activities Uma has done before. These are the set of people Uma is connected to and so on, right. It's also going to look at the models, right. So is which model should I serve Uma? At the moment there are 100 models running for jobs platform, and this is the right set of models. So it's going to load that. Then the query comes down. This is actually the job index. So this works like the typical parent-child kind of architecture. I'm calling them as broker and searchers, but imagine this as a parent, and this is a distributed architecture. The same query is going to like X different hosts. Each host has a certain set of jobs so that it can execute the same query. So let's say I talked about the candidate selection, right? Give me jobs from this geo having this title and this skills. That is going to execute it here. So this job searcher will, let's say, return 1000 results. This will return 1000 results and so on. So the broker, let's say if we are working with 10 charts, it will have 10,000 results. It passes on these 10,000 results to the mid tier here. So at the mid tier again, it has the models. It's going to run your deep neural network and give you the ranking on these 10,000 models. And then it's going to either here or here, it's going to apply those business rules that I talked about, the impression discounting, the inserting of ads and so on. Yeah? Questions? Clear? Yeah.
Alright, so can there be a probability-based recommendation for a job? Like the success that candidate who get that job, they depending upon that, those jobs are only recommended and not all.
That's a great question. So this is actually a premium service that at least LinkedIn offers. See, the base model that we train is about peak click, that whether I would click on this job. But beyond that, okay, whether I'm even qualified, maybe I'm applying for CEO Microsoft. I'm not going to get that job anyway, right? But the premium service that we offer is that probability whether I can get this job is another model that runs on top. And when I say premium service, there is something called as LinkedIn Premium, where you get these insights, that these are the you are one of the top 10 candidates in these XYZ jobs. So that balances out both sides, whether I'm interested in and whether I'm qualified for.
So like if there are, like everyone don't have a premium subscription and majority are...
Oh, sorry, I want to add a caveat. I mean, of course, the base model will also do these kind of checks, right? When I talked about the signal, so cleaning of the data. right? So that in the data cleaning, the seniority level of a person and the seniority level of the job, that will be taken into account while we are cleaning the data. So that will ensure that Uma and Microsoft CEO, that's probably not the right fit, let's throw it out from the training data. Because there are such examples in our training data right now, and they are screwing up our recommendations. So we have to ensure that we have to weed out these examples from the training part itself. Ranker and re-ranker, why can't we merge them? So if I understood your question correctly, you are talking about why can't we merge ranker and re-ranker, and you are giving a method it could be merged, right?
Like if we can't merge, so why we can't merge? Like
why we can't
merge
merge?
the different-
Yeah, because finally it's a, at the end it's a statistical system, right? It's going to give, like, it's optimized for the best way I could do things, but it's going to make some mistakes because your training data is not clean, because you have some infrequent members, you don't even have data for them, so it's going to make some mistakes. So you are allowed to make certain mistakes, but the business states that these are XYZ mistakes you cannot do in any case, so we just apply them as rule at the top. So that's why necessarily we can't merge them.
So is it like the ranker level layer is common for every businesses, and then for specific businesses we will use a specific re-ranking?
So when you say businesses, are you talking about general recommenders, like not just, I'm talking about LinkedIn case, but are you talking about general cases?
So like for the LinkedIn only, like if I am searching for a job, okay, and if you are recommending me a job, so first there will be a ranker layer, right? So it will give you 4 jobs. Then you are having a re-ranking layer that will arrange these 4 jobs in different order, depending on, as you said, the same job should not appear, or a similar job from the same company should not appear, something like that, right?
Yes.
So the re-ranking layer is specific to me as a user, or is it specific?
It's common across all users.
It's common for everyone.
Yeah, yeah.
So then we can just, like, as soon as ranking layer is done, we are trying to put the re-ranking layer, correct?
Yes. Actually, let's take that offline. I'm happy to talk to you in lunch, because yeah, it's already 12:30, right? We have started late, but I want to make sure I want to complete this. All right. So I talked about the job recommendation. I want to take a moment to talk also about the other kind of recommenders LinkedIn has, which is the feed, right? What is feed? When you land on LinkedIn, your home page, it has, your connection, first degree connection has posted about this. Or you are following Satya Nadella and he has posted this. Or these are some set of job recommendations for you. These are set of people you can connect to. All these recommendations come directly on my home feed, and that's the feed recommender. Now, as you can see, the feed recommender is even more complex than job recommendation. Why? First, the scale. Okay, the number of job seeker base on LinkedIn is actually smaller compared to the number of people who come there to network, to gain information, right? So you have to satisfy even more users. Secondly, number of jobs is again lesser than the number of posts that are being generated over the course of time. So as you can imagine, because feed collates different type of data, the complexity is higher. Secondly, jobs are mostly text, but when you talk about feed, you have images, you have text, you have videos. So whatever mechanisms you have to gather signals have to be multimodal. Thirdly, trust. In jobs, we have to make sure that we are not putting any fraud jobs there, which are asking for money and frauding people. On feed, there is even a bigger problem. There shouldn't be any spam, hate speech, any kind of misinformation. So there is a huge trust team that works out of Bangalore and out of Sunnyvale, Mountain View as well, that works on making sure that we implement these kind of solutions which keep members' trust. Coming back to what is the difference between feed and job recommenders, you need to have more layers in the model funnel. I talked about the 3 general layers. But sometimes you may even break down between candidate selection, again you might want to break down, right. So more layers. The business rules are again more complex, because you need to maintain balance. Oh, how many posts I can show, how many ads can I show, I need to insert one job recommendation there, one people recommendation there. So that final layer again becomes more complex, and the infra that needs to support this, again as you can imagine, is much more complex. All right, we did talk about challenges. I want, because I want you to take a moment to appreciate this. So first I talked about the scalability, and the solutions we talked about, okay, distributed systems, pre-computed features, building a funnel model, right. So that's a reminder, that's the first challenge I had. The second challenge, somebody already mentioned, right, what about the cold start problem, data sparsity problem, right. So what is cold start? Let's say my model is I have trained it over some many months of data, it's working fine for some users. Now a new user comes in, they don't have any data. I don't know what this user, maybe they have put their job title, maybe they have just put their what kind of jobs they are looking for, but they don't have any history of doing actions on the platform. What recommendations can I do? Okay, I'll talk a bit about solutions also, but let me just go over the problems first. So yeah, the new people I talked about. LinkedIn also, or in general any site has a lot of infrequent visitors as well, right. So these people, because they come infrequently, let's say I'm trying to sample 1 month's data to train my model, but there are going to be users who come maybe once a month, right. So necessarily their data is going to be very small compared to the people who turn out every day or maybe once every week. That's another problem. Sparse member profiles I talked about. People just, some people may not fill up all the information they have that can be used by the algorithm. And earlier I referred to how we use members' data to train tomorrow's model. But somebody already mentioned that this could lead to a sort of vicious cycle, right? That today's actions are going to bias tomorrow's model, right? I want to give a few anecdotal examples. So when I joined LinkedIn, I was given this problem that, okay, we have a lot of blue collar members here on the platform. What is blue collar? They don't need any college degree to do their jobs. So cooks, cashier, front store receptionist. And we were making mistakes for recommendation for this user. One anecdotal example was a person was a fry cook, and we were showing them some senior manager or those kind of jobs, which clearly they were not going to get. And the problem was because people were trusting the system. What's the harm in applying to this job? They would go and apply on this, and then that would go in the training data, and we would show them more jobs. This kind of vicious cycle continues. So the solutions to all the, some of the solutions I can speak about is we need to break this cycle. So one simple thing that worked is just put rules in the training, your training data as well as in your serving, that I will have some kind of seniority rules in there. I will not show a person a job they are not, they may not be qualified for based on, let's say, the difference in seniority. That was one. Secondly, I had to make sure that our understanding of these systems, these members' profiles improves. So to give an example, if a person says I'm a VP in finance world, that means very different from what it means in the tech world, right? So we use internally some kind of standardization mechanisms to make sure, oh, this title internally means this kind of seniority or this kind of job titles. That mechanism was not working well for this blue collar member base. So we had to sit down and fix that first, fix our taxonomy. Finally, once all this was done, we had sufficient amount of training data. We had to make sure that the model was seeing it, right? There was right set of samples available for all kind of training, the blue collar member base, the white collar member base, and then we trained the model and released them, right? So you need all sort of these mechanisms to come together to finally measure the members, whether, doing the right thing by the member. Okay, so these are one set of challenges around the data part. ethical issues. This is a big problem for any kind of recommender systems, right? So misinformation. I mean, I'm not talking about LinkedIn here, but recently, few years back, there was this Pizzagate example where some people, you know, as a joke, they started talking about, okay, maybe if I call for a pizza, this actually is a signal for human trafficking. And then some people took it seriously, and it actually led to one person showing up with a gun to a pizza parlor because they wanted to rescue people, right? This is misinformation taken at a very extreme level. We have these kind of examples in some form or others in all social recommender systems. We have to make sure the right set of guardrails are in place. Fairness is a big issue. If I am showing job recommendations, am I doing the, so let's say an extreme example would be, I show CEO jobs only to Caucasian white males and I am leaving somebody else out, right? That's not a fair thing to do, obviously, right? So I need to make sure, I need to first establish, measure whether this is happening or not, and if it is happening, how do I correct it? By maybe having the right set of, again, data, making sure the model is looking at this data and learning from it and so on. Explainability. Right? If I am showing certain jobs to the user or certain articles to the user, I also need some form of explanation sometimes that why did I show this job. Security, privacy, Karthik also already talked about some of these, so I will not go into details, but these are real issues. If a member is trusting me with their data, their actions, I want to make sure that these are used only to show them right recommendations. These are not being leaked out somewhere. So I unfortunately don't have time to go into all these details. I have given some links here though on how do we do special intervention to limit bad content and also for responsible AI. Please go through this. All right, finally a few minutes on the trends and takeaways about large scale recommender systems. First is a no-brainer. We moved from, you know, the logistic models, the tree-based models to the deep learning-based models. The second trend I am seeing is the gathering, like sharing of signals. Don't design a recommender system based on just, you know, the siloed application of jobs. But LinkedIn, for example, is in a very good place where you have the ecosystem of the job, the member, the people who are offering jobs, the recruiters, people, then there are courses people can take to upskill themselves and so on. So I am working on an initiative to combine all of these signals. It's already in production, we are using it, but we can always make it better. So using multitask learning, can we combine these signals and do the right thing for the member? And finally, reinforcement learning based models. This again is available, is used in some form or the other in all the large scale recommender systems. Most simpler being Thompson sampling, some kind of multi-arm bandits to gather users' preferences, show them some data and gather their preferences. Okay, so that brings me to the takeaway slide. We talked about large scale recommender systems. What was the goal? Search system are when I know what I want, I can give the exact query, but recommenders work when users may not be able to articulate their query and the system still wants to gather information and show you recommendations. So it's serendipitous discovery. We talked about ABCs of scale, how we divide the model into a funnel. We talked about how we use user actions to train models and the platform, the training side as well as serving side that is needed to do recommendation and skills. Talked about the challenges, cold start, data sparsity, ethics and so on. And finally the trends. Okay, that's the end of my talk. Thank you. Oh, ChatGPT. Yeah, that's a good question. Okay, let me give you some practical examples. So, when we are talking about feed, right, where the goal is to get people talking, and why do people come to LinkedIn? They want to gather some knowledge or like they want to get some job and so on, but main feed is where people want to gather knowledge And that's the use case we want to power. Okay. So one use is, of course, you can ask ChatGPT and show it, but that's not, I mean, it has problem. This is not people talking to people, right? It's not conversation. And B, ChatGPT has its own set of problems, right? So that's not the ideal. So the middle path that the test is currently running, so I can talk about it, it's public, is where we could take some initial, people find it easier to comment on something rather than creating something from scratch. So why don't we get ChatGPT to give us some content and then invite the actually knowledgeable people in a field to start conversing about it. So they can comment and critique and so on. So this is one way we could use it as a co-pilot for a field recommender. For job recommender, the way it could be used as a co-pilot is a lot of people find it difficult to express their skills about me section, right? For example, people feel like, oh, am I bragging about me? Like somebody may feel it and they would be at a disadvantage compared to somebody else who is good at it, right? So can we now bridge this gap using ChatGPT? Can we get people to write the ideal resume, like resume helper, right? So these are some of the ways. The common theme in all of these is the large language models would be used to democratize opportunities and used as a co-pilot mode so that we don't use it to enforce the mistakes that it is making, but rather as a starting point.
Maybe one last question, and then the rest can be taken offline.
I was wondering if there is any adaptiveness to the model through the pipeline in the service.
Adaptiveness?
Yeah, you can configure the model somehow. I don't know whether it's possible. Is there a combination where different variant of the model, a different model gets used in the pipeline, depending on some other method? Because that probably has some implications on accuracy or whatever metrics of accuracy and resources.
So one way it could be used is we want to get clever on the A/B testing, right? I have maybe 10 tests to run, and initially I show them equally, but I know that one test is not, I mean, classic example of multi-arm mandate is one test is not doing well, you take it out, and this second test or third test, these are doing well, I show more and more them. So that's kind of adaptiveness I can foresee. Yeah. Yeah, okay. So I am happy to take any further questions offline. Thank you for your attention.